Chapter 4, Section 4. We've already graphed sine and cosine. We just got done graphing cotangent and tangent. Now we're going to graph secant and cosecant and figure out how to graph those using sine and cosine. Okay, so let's take a look at the secant function. Remember, the secant function is the inverse of the cosine function. So a lot of it's going to have kind of some of the similar attributes to what cosine has. Now, one thing we got to pay attention to, okay, is secant is going to have asymptotes. When do those asymptotes happen? When cosine is 0, right? Because secant is 1 over cosine. So whenever cosine goes to 0, we're going to be undefined with secant. So at pi over 2, negative pi over 2, all right, all those as it goes around, okay, 3 pi over 2, wherever cosine is 0 is where we will have our asymptotes. So you can kind of see where we're going to be undefined here on the chart. The range for secant, all right, goes anywhere from negative infinity all the way up to negative 1, and all right, that's what that big U means. We're incorporating two sets there. It also goes from 1 to infinity. That'll make much more sense when we do the graph. All right, so the domain is going to be based on when cosine is 0. All right, that's why we have 2n plus 1 times pi over 2. All right, and the range, okay, it cannot be a value that's between negative 1 and 1. All right, so let's take a look at what that graph looks like. This is a graph of secant. So for you to graph secant in your calculator, you're going to have to graph 1 divided by cosine of x, and for your y1, and then hit zoom 7, and you'll get the graph of secant. Look at secant versus a normal cosine graph. Alright, so secant is literally going to mirror cosine, except for we're going to have asymptotes instead of continuation. So you can look at the graph on the left, right? Secant starts at 1, goes to infinity. Secant starts at negative 1 and goes to negative infinity. And then it alternates back and forth. Another way to relate is just, remember how cosine starts on the y-axis. Secant will also start on the y-axis. Okay? So, where are the vertical asymptotes? Whenever cosine is 0. Cosine, the first 0 for cosine is at pi over 2. Alright, so if we take a look at this, and if n is 0, we get 2 times 0, which is 0, plus 1. 1 times pi over 2 is pi over 2. Alright, so cosine of pi over 2 is undefined, or cosine of pi over 2 is 0. Secant of pi over 2 is undefined. If n is 1 here, we get 2 times 1, which is 2, plus 1, which is 3. So we have 3 pi over 2. Okay, so cosine of 3 pi over 2 is 0. Secant of 3 pi over 2 is undefined. So we can keep substituting in numbers for n, and that's what's going to happen. We're going to have an infinite amount of asymptotes. So one thing about secant, unless we do some sort of vertical shift, there are no x-intercepts, and its period is 2 pi, just like cosine's is. There's no amplitude on this, okay? So there are no minimum or maximum values. We can change the value in front, and you'll kind of see where it goes, but since it can go from, like negative infinity up to a certain point, and from a certain point up to infinity. All right? And it's symmetric with respect to the y-axis, which makes it an even function. Okay, so I can only fold it over the y-axis, where most of the other functions were odd, right? All right, let's take a look at cosecant. Remember, cosecant is the inverse of sine. So whenever sine goes to 0, that's when cosecant will be undefined. All right, so sine of pi is 0. Cosecant will be undefined. Sine of 2 pi is also 0. Cosecant will be undefined there. The domain, okay, for cosecant is n pi, right? Where if we have 1 pi, 2 pi, 3 pi, 4 pi, because that's wherever sine is 0. Okay, so that's where we're going to have the asymptotes. The range for cosecant is the same as secant. Alright, so we have negative infinity all the way up to 1 and including, all the way up to negative 1 and including it, right? Because there's a bracket. And then the U means and, right? We have 1 including 1, right? All the way up to infinity. And if we were to graph cosecant, all right, this is what we would see. So in your calculator, you would do 1 divided by sine of x, hit zoom 7, and you'd be able to get this to come up. All right. So notice where the asymptotes are. The asymptotes occur at pi, 2 pi, 3 pi, 4 pi, so on and so forth. All right. So this graph is a mirror of sine. Okay, a mirror of sine. So we'll take a look at that as we start doing these graphs. All right. So the cotangent function we've already talked about, right? But how does that play a role? Remember, cotangent was what? Cosine over sine. So whenever sine was 0, all right, we did everything with cotangent last time. And so all of this is for cosecant, okay? But the cotangent is technically an error on this one, okay? So at the top that should say cosecant, not cotangent. So some of these slides I just add to them. I get them from the publisher and things like that. So this slide is one of theirs. So at the top, sorry, don't write cotangent. All right, any of that. This should say cosecant at the top. So I'm going to go ahead and switch that. All right, now that's corrected. So we should be doing the cosecant function, not cotangent at the top of this. All right, so no confusion there. All right, but last part of this though is there's no max or min on this graph, sorry, but it is symmetric with respect to the origin, so this is an odd function. So secant was the even function, cosecant is the odd function. Recapping period for this 2 pi as we go through. All right, and like I said before, for us to graph these in the calculator, to graph cosecant, you're going to have to hit 1 over sine x and then hit zoom 7. All right, and graphing secant x, you're going to have 1 over cosine x, hit zoom 7. So it puts it in a nice trig format. So when you do that, all right, on the left-hand side, all right, there's a mode on your calculator that shows how we can do like connected and things like that. It won't show the asymptote. All right, but if we take a look here on the left-hand side, all right, if you guys don't remember how to shade, see if you look to the left of the y1 and the y2, you can change what the actual graph looks like. So you can move your cursor all the way over to the left and hit enter. It'll make that line thick, it'll make it thin, it'll make a little bubble that animates through it, and so on and so forth. And you can just do it that way. But here's what it's like plotting them together. So we see sine versus cosecant. So we can see how cosecant is a mirror of sine, right? Because it's its inverse. Same with cosine, all right? We can see that secant is a mirror of cosine, so we can see, how secant bounces up. So when cosine has a maximum, all right, that's when secant's going to have a minimum. And then when cosine has a minimum, that's when secant's going to have a maximum. We can say the same thing with sine and cosecant as well, right? When sine has a maximum, cosecant will have its minimum, and then when sine has its minimum, cosecant will have its maximum. So just kind of a way to interpret those graphs, okay? Now, we're going to graph them using the parent function of sine and cosine when we do these graphs. So if you graph them by hand, sketch a graph of cosine first or a graph of sine first, then do the corresponding secant or cosecant graph. Okay, so the first step when we do it, graph the parent function, then graph the vertical asymptotes, alright, so we know where it's not going to cross, and then make our U-shapes there based on the coefficient in front of cosecant or secant, alright, and it just makes it easier if we do an example here. So we're going to graph y equals 2 secant 1/2 x, alright, so that 2, alright, that's where secant's going to drop down to. So secant's going to be from 2 to infinity and from -infinity to -2. So that's where the secants are going to bounce from. Alright, we still have to figure out where the asymptotes are going to go. Alright, and we notice that b is 1/2. So we have to find our period here of this function. Okay, so the first and easiest thing to do, we're going to graph cosine first. Alright, so we're going to graph cosine. Y equals 2 cosine of 1/2 x. So we have to, set, our normal period is what? 0 to 2 pi. So we have to find out what's happened now. So remember from sine and cosine, when we graph these, we have to do two parts of the inequality here. So we're going to do 0 is less than or equal to 1/2 x and solve for x. And then we're going to do 1/2 x is less than or equal to 2 pi. Alright, that's going to give us our asymptotes. Okay, so when we do this, 0 is less than or equal to 1/2 x, x will be 0, and then we do 1/2 x is less than or equal to 2 pi, solving for x, we get 4 pi. Alright, so this graph is going to go from 0 to 4 pi. Okay, then we have to find the key interval points. This is repetitive now. You're going to go 0 plus 4 pi divided by 2, that's 2 pi, so that's our minimum, our midpoint. Alright, and then we have to find our quarter point, so we're going to take 0 plus 2 pi divided by 2, so we're going to get pi, and then we have to find our 3/4 point, so we're going to take 2 pi plus 4 pi divided by 2, and we're going to get 3 pi there. Alright, so that's our 3/4 point. So now we have to substitute in all of our values, our left and right asymptote piece, and then our quarter point, our midpoint, and our 3/4 point. So we're going to plug that in. When I plug in 0, I get back 2. When I plug in pi, I get back 0. When I plug in 2 pi, I get back -2. When I plug in 3 pi, I get 0. When I plug in 4 pi, I get 2 back. That you're substituting into the cosine graph. So you're substituting those values into y equals 2 cosine of 1/2 x. Okay. When you plug those in, you're going to plot all the important points on the cosine graph. Alright, so you're going to plot its trough and its crest of its waves, or the amplitude, right? So where it's 2, you're going to put a dot, and where it's -2, you're going to put a dot. Then where you're crossing 0, alright, so pi, -pi, 3 pi, you're going to put a dot. And then we're going to connect those with a dashed line, because remember, we're just using cosine as a reference guide here. Alright, and then we know what? When the cosine graph is crossing 0, those are going to be where the asymptotes are for the secant graph. Okay, so now that we've plotted all the points, we plot the asymptotes, alright, right when cosine is crossing 0, and then we put our u-shapes in, okay, right at the max and min of cosine. So the graph here in blue is going to be for secant. Alright, so it's 2 secant 1/2 x. Alright, so remember the steps we did for this. It's just like we did in this first section of this chapter. Alright, we graph the sine and cosine function, and then we use those specific values to graph the secant or the cosecant function when we do this. Alright, so let's do a cosecant function. So this is y equals 3/2 cosecant of x minus pi over 2. I'm not going to get too much into detail on this one because it's very repetitive what we've been doing this entire chapter. We're going to turn this into a sine graph. Okay, so first we got to turn it into sine so that we can sketch the parent function of sine, and then we'll use sine to graph the cosecant. We have to do what? Find the left and right asymptote, right? So the period. So we have to set that up. Alright, so the period in this case is 0 to 2 pi still. When we're going to do this graph, we have to pay attention to any shifts that were made and any amplitude changes. Okay, so notice the amplitude is 3/2, so that's the highest this waveform gets, is 3/2 and -3/2. Notice it's a sine wave that is shifted to the right pi over 2. So you should be able to do this sine graph pretty much in your head. The amplitude is 3/2, and it's got a phase shift, and we've shifted left. Alright, we've shifted right pi over 2. Alright, because that's what makes the argument go to 0. From here, you should easily be able to sketch the asymptotes. So when is this graph at 0? It's at 0 at -pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2. So sketch your asymptotes there, and then put in your u's. Alright, pretty simple. We put the asymptotes where the sine functions go into 0, and then we put our u's, or our u branches, at the maximum and minimum, or the crest or the trough, of the sine wave, and then you would erase your sine graph, and have your sketch of cosecant. Alright? I think these are pretty self-explanatory, doing the secant and cosecant part, because it's really just hashing through regraphing sine and cosine functions and then using those as parent functions to graph the secant and cosecant. Alright, let's go the other direction now with an example. We want to determine the equation for this graph. Alright, let's start by analyzing this. To me, right, is the first u, is it on the y-axis or off the y-axis? It's off the y-axis. So for me, I can relate this to a sine graph, but it looks like it's an inverse function, right, because we have the u brackets. So it's going to be a cosecant graph. Okay, nothing in front of the cosecant term, but what is changed here? Okay, the period. Instead of going from 0 to 2 pi, the period is now 0 to 4 pi. So that's really the only part we got to think about here. It looks like, you know, the middle of the graph is still at 0, so there's no vertical shift. All right, but then there's just a stretch. So we have to use our b. All right. So remember, the period was 2 pi over b. So we have to find b. So we're going to say, we can see the period is 4 pi. So it's going to be 4 pi equals 2 pi over b. Okay, and then we have to solve that for b, and we end up getting 1/2 for b. Alright, so that's probably the hardest part of this problem, is finding the b value. But we remember we used b before to find the period, right? We said 2 pi over b was the period. So, but now we're given the period, so we have to find b. So the period is 4 pi. So 4 pi equals 2 pi over b, and solving that for b, we get 1/2. And then essentially we can just fill it in, right? Y equals cosecant of 1/2 x. Alright, so that one should be pretty straightforward if we're, you know, interpreting the parent function there as a sine graph. Alright, let's take a look at this one. Now this one's a little bit different, right? Because look at our middle value on this one. Our middle value is at 1. So to me, this graph looks like it's what? Been shifted up. And we have a period change, do we? Yeah, because it's normally going to be what? Okay, we've still got a period of 2 pi for cosine. Alright, but look at how this stretches here. Okay, so we should assume this is a secant graph because the graph is starting on the y-axis as well. Alright, so I'd be able to draw a cosine sketch and have my 1 as kind of my middle value. So we can really see that this is just a normal secant graph that's been shifted up 1 unit. So for this one is just 1 plus secant x. Okay? So just so we know that we can create all kinds of new different functions by adding trig functions together. Alright, so we could say, alright, we got y equals cosine x plus sine x. So you could graph them separately, or you could graph it together and plot points and calculate the different curves. Okay, so this is really how we're going to get it. But what you want to see here is your calculator terms. Alright, if you put cosine into y1 and sine into y2, y3 you can either say is cosine x plus sine x, or you can use the y1, y2 variables in your calculator, since you stored cosine is y1 and sine is y2. Alright, but we can see what the addition of those two curves does to each other. Okay, so just something to think about for this section. But just remember, when we're graphing secant and cosecant, what you need to do is graph, you know, cosine and sine first, and then sketch your secant and cosecant based off of your sine and your cosine graph. You know, we've had a lot of practice in the first couple sections of this chapter graphing sine and cosine, so it should be relatively natural for you. You just got to make that small adaptation to be able to graph the secant or the cosecant function based on the cosine or the sine function. Alright, that's it for me on this one. So with the go ahead and email me with questions, or those of you guys sitting in class, I will be answering questions on the board as well. Alright guys, take care.